My name is Christopher Ong. I work as a project engineer here at Pivotal Engineering. Pivotal Engineering is an engineering firm that provides services in engineering, management and consulting. We primarily focus in the areas of operational technology and process automation.
Chris Murphy, I'm a lead control systems engineer at Pivotal Engineering. Pivotal Engineering is a really dynamic, forward-looking company that is always looking to embrace new technologies and ideas to solve traditional problems that our clients present to us.
This project with Westgold was primarily to replace the existing Cytic SCADA implementation that they had on site with a modern, scalable ignition SCADA.
Part of that was to do that in parallel with the existing control system so that we had no downtime at the plant.
So I'm James Hodell. I'm the Group Manager for Electrical and Projects at Westgold Resources. We're a proud Australian gold mining company. Bluebird's a historic mine and it's one of our key assets that we have there. It's had a lot of owners over the years. Westgold have had it for over 10 years now. With the existing SCADA that we had, for us we didn't give us enough room to move and grow. So that was the issue that we had with that and the reason why we sought to go with ignition. So we approached Pivotal Engineering to modernise our SCADA system.
The purpose of this project was to create a modern ignition SCADA system that would replace the legacy SCADA system.
My name's Sang. I work for Pivotal Engineering and I'm a control systems engineer. The first biggest requirement that they had is having operational continuity, which basically means that the new system had to have all the features that the existing system did. At the same time, developing a system that could work alongside the existing system to have zero downtime during the migration process. The second biggest thing that they wanted to achieve was developing a standard, something that they not only use for their Bluebird mine, but that they can use and expand and implement on all their other assets. And lastly, they wanted to have a focus on their alarming, standardizing the descriptions and the way alarms are presented to the operators. There's a lot of different solutions that are out there for doing alarm aggregation and ignition, but we leverage the power of SQL databases and ignition together to come up with an alarm aggregation solution that lets you aggregate alarms at every single level.
Westgold's using ignition to control their processing plant at Bluebird, all the way from crushing through milling and grinding and the elution circuit.
Ignition SCADA is being used as a platform for more technical personnel such as electricians and engineers to troubleshoot when there are any issues with the plant.
Westgold is using ignition perspective to control and operate their process mine, controlling all their equipment, monitoring the state of the plant and also reporting.
So we're using it for just now for display and control of all of our SCADA at Bluebird mine site. But now we're looking at our underground projects and anything that's new now, we're starting to say, well, maybe we can do it with the ignition. So we're doing like dewatering projects and underground fan projects. We wanted to ensure that whatever we delivered now, there would be more security. Who's accessing this, not just as a work group, but individuals as well, that would be important. We wanted a cleaner HMI. The initial one we had was quite busy and noisy.
We decided to follow through with using the Abnormal Situational Management Consortium's guidelines, which meant that the use of colour was very strategic.
We took an existing ASM guideline that had defined all of the colours in great detail and design strategies, and we decided to mostly stick with that. Because within perspective, a pop-up can't leave the window, we chose to remove pop-ups completely and we switched to a docked view configuration so that faceplates for equipment come up in a bottom dock and we have side docks and a top dock as well. Sticking with ASM, that we don't cover any parts of the page that are critical for the operator, so they don't inadvertently leave a pop-up laying over the top of some hopper that is in a high-level alarm, for example.
Every little detail on how things were presented was strategic as well. All the font sizes had to be consistent across the page. Everything is visible to the operator and the status of if something's enabled or disabled is just a scale of grey to drive the operator's attention. So getting them from being very reactive to being a bit more proactive, so they can put their attention towards what needs their attention the most. And then the last thing that we try to achieve is, instead of them controlling the plant based on its current state, we wanted to give them a bit of behavioral information. So looking at 15-minute trends, because quite often their inputs won't have an immediate impact on the plant. So having a quick and easy way for them to view that data on their main screens meant that they could make better decisions on if something that they've changed has worked positively or negatively to better control that plant.
We also created some features to allow the supervisors to be able to change the minimum and maximum operating values of the analog equipment, showing shading as well on the graphs to indicate to the operators what the ideal process operating range of that piece of equipment would be, so they wouldn't have to guess how they should be running the plant, but know what the optimal performance should look like just by looking at the screens. When Westgold first approached us with this project, one of the biggest requirements they had was that the new ignition SCADA had to be able to fully replace the SciTech implementation that was currently on their site. The new SCADA had to have at least all the same functionality of their existing SCADA, but also improve upon it. Also were requested to implement it without incurring any production downtime.
The aim was, through this project, to not make any logic changes in the PLC because we had to leave the traditional SCADA system running in parallel.
Making modifications to the control logics was out of the question. Apart from that, we had to come up with a mechanism that would let us build a standard that won't only work for the Bluebird Mine's PLC standards, but also something that can be taken to the other mine sites. So building in a level of abstraction away from the PLC standard at Bluebird. It's a risk mitigation strategy. So any disruptions to the process has safety impacts and financial impacts. So having them run side by side just provided a safety net to the supervisors so that if they are dealing with an ongoing issue, especially during the training phase, they could always revert back to the old system that they already knew where things were.
One of the things that our engineers had to look into was also the firmware versions on the PLCs, the driver compatibility and the mix of the different versions of PLCs on site, as they hadn't been updated to the most recent versions. And that meant a bit of a technical challenge in that both Chris and Sang had to upgrade those PLCs to the right firmware without incurring any shutdowns, but also not investing too much time into a legacy system that they were going to decommission at the end of this project.
The plan is post rollout that we will be making some PLC modifications and changing how ignition is interacting with the PLCs slightly.
It was the scalability that really attracted us. When we looked at this and we thought we could grow more, there's not a limited tag count, you know, we were kind of put into a corner with that. So scalability, yeah, that's it. I mean, that's the biggest thing we were looking at was how can we have a system that will grow with our mine and our plants. You know, we've got potential issues to grow the processing plant and we need a system that can grow with that. That was one of the pains that we probably had. We've got an old legacy asset there that with the system we couldn't really move much. Now we can. Bluebird was, I guess, a good trial for us. It was a big thing for us to do. So we've already implemented it on smaller projects as well. Having looking at this, it's been a short time since it's been implemented. But yeah, we've got big plans of moving this on to another processing plant after this one. So big plans.
Now that we have an unlimited tag count, we can add a whole bunch of extra equipment that wasn't able to be on the previous SCADA. We can also add other more administrative tasks and reporting into the SCADA system. So previously that wasn't really an option, but now we can move to putting certain processes like change management and bridge management into the SCADA system where that was separate out in paper-based systems.
This was one of the simplest processes that I've gone through in deploying a full SCADA system. So it took us probably about an hour to get a full set of redundant pairs of gateways, communicating to the PLCs and historizing all the data with all the screens there. So it was pretty smooth from that front.
What we tend to find with mines like this, not so much with the surface operations, but a lot with the underground operations, is that the equipment and the placement of the equipment can be quite dynamic. And what ignition allows is for things to come and go and for us to dynamically create and remove whole tags and equipment into the structure as required. When it comes to having equipment that moves around the plant and might be part of one area one day and a different area another, It's very, very easy for us to manage that within Ignition versus other SCADA platforms.
Ignition was the right choice for this project because Ignition comes out of the box with a lot of features that don't often come with competitor SCADA platforms. Ignition allows our engineers to work with a modern solution that works cross-platform, works with a variety of databases, and it comes as a cost-effective option to our clients. And all this combined really frees up time for our engineers to focus doing the work that really matters, doing all the creative design, and putting a lot of thought into delivering the solution to the client, which they would otherwise spend setting up the framework for the project.
So far, there's a lot of positive feedback from the team, so they've adopted it very well, so yeah, it's good.